Okay, this is the second part of the lecture for linear systems. In the last lecture, the first part, you saw that we had three linear systems, or three linear equations, and we found the solutions to those systems of linear equations when we set one equation equal to the other. And if you understood that lecture, this part's going to be, I think, a little bit easier. Because, we have this, which was where we had one solution, one line intersects another, and there's three types of linear systems. You can have two lines intersect each other, and that point of intersection is going to be the solution. Or you can have two lines where they're parallel to each other. That means they never intersect. So if the point of intersection is the solution, but they never intersect, that means there's no solution. And then the last type you can have is where you have two different equations, but when you simplify one of the equations, you realize, or when you graph it, you realize it's the same exact equation. Well, if it's the same equation, then those two lines are going to intersect on every single point along the line. And that line goes on infinite for an infinite amount of time, or distance. So that means there's infinitely many solutions. So these are the three possibilities you can have for a set of two linear systems when you're solving for their solution. So the first thing you always want to do when you have two equations is simplify it. So you have it in the form of y equals mx plus b. And then you're going to look at its slope, the slope of the two lines. If the slope is the same, that means they're parallel lines and there's no solution. So you don't have to do anything from there. If the equations are exactly the same after you simplify it, then that means there's infinitely many solutions. And if you see that the slope's not the same and they're not the same line, then you know there's a solution to the equation and you can look at it that way. So go ahead and copy this into your notes. We're going to be working with two linear equations and looking for their solutions. And I'm going to show you how you can tell if there's no solution, if there's one solution, or if there's infinitely many solutions. So for that last one, I'm just going to give you an example for when you have two equations that are exactly the same. So let's say you had y equals 2x plus 3, and then you had 2y equals 4x plus 6.
No.
Well, you can't really tell right now, but these two equations are exactly the same. If you divide by 2 on both sides, then you're going to get y equals 2x plus 3. And we can do that because we're dividing it on both sides, so we're not changing the equation at all. And this are exactly the same, which means there's infinitely many solutions. Whatever you plug in for this equation and whatever you plug into this equation are going to give you the exact same output, so you're going to get the same point on the line. So that was just an example of the last one for anyone who was having trouble picturing it. So there's two ways we can find the solutions to a system algebraically without having to graph it. The first is substitution. Okay, so how do we do substitution? The first step is to solve one equation for y. Then plug y in for equation 2. And that's going to give you an equation of only x. And then the third thing you're going to do is you're going to solve that equation for x And then you're going to plug x in for equation 1 or equation 2. It doesn't matter which one at that point because you already have the solution for x. You already have the x value, and the solution is going to be the same no matter which equation you plug it into. And that's going to give you the value of y.
Oh, it does.
And then you're going to check your solution by plugging in x comma y and making sure the left-hand side equals the right-hand side. So go ahead and pause the video and write all that down if you need to. We're going to move on to an example of the type for substitution. Okay, so our first equation is 5x plus y equals 13. And our next is 3x plus 2y equals 12. So we can solve for y from this equation very easily because y is by itself. And here it's 2y. So we'd have to subtract the 3x over and then divide by 2. This one's easier to work with. So we can change that to y equals 13. And if we subtract 5x from both sides, that's going to cancel out. So we're going to get 13 minus 5x on this side. Sorry. Okay, so now we have y equals 13 minus 5x. So we're going to plug this value of y not into this equation, but into the second equation. 3x plus 2y, where y equals 13 minus 5x equals 12. So we plug that in right there. So now you can see all we have are x variables. We don't have y variables anymore, so it's easy to solve for x. So we have 3x plus, distribute the 2, so 2 times 13 is 26, and then 2 times a negative 5x is a negative 10x, equals 12. Now let's combine like terms. 3x minus 10x, and then we have the 26. So we have 26, 3 minus 10 is negative 7, so minus 7x equals 12. Now let's subtract 26 from both sides. That's going to cancel out and we get negative 7x equals 12 minus 26 is negative 14. Now we can divide the whole thing by negative 7, and we get x equals negative 14 divided by negative 7 is 2. So x equals 2. I'm going to put that right here in red because it's our solution. Okay, so write all that down. I'm going to erase that. Okay, so now that we know x equals 2, we can plug it in for either of the two original equations. Usually you want to plug it in for whatever looks easier. If we plug it in here, there's going to be a lot of work still moving around to solve for y. This one's easy. So we have 5x where x equals 2, so we're going to plug that in right there, plus y equals 13. 5 times 2 is 10, plus y equals 13. Let's subtract 10 from both sides, and we get y equals 3. Y equals 3. Okay, so now we have our solution, which is a coordinate. So our solution equals a coordinate, x comma y. where x is 2 and y is 3. So if you open up your graph, the linear system graph that I made for you, I graphed these two equations. 13 minus, I solved for y, so y equals 13 minus 5x. That's this equation. And that's going to be in blue. And this equation I solved for it also. I subtracted 3x on both sides, so you have 2y equals 12 minus 3x. And then I divided by 2, so you get y equals 6 minus 3 halves x. So those are just, this is your blue equation on the graph. And this is your red equation on the graph. Just so you guys can see that a little bit better. And if you notice where the graph intersects, where the two lines intersect, on the x-axis, you go over to 2. So that's x equals 2. So that's good. Now let's check 3. So if you look at your graph, and you follow the point of intersection to the left, it's going to intersect the y-axis at 3. So that's correct, but we can also check it by plugging it in for both of these equations. So let's go ahead and plug that in. I'm going to do that in green right now. So our first equation is 5 times x, which is 2, plus y, which is 3, equals 13. 5 times 2 is 10, plus 3 equals 13. 13 equals 13. That's good. So it works on the first equation. Now let's check it in the second equation, which is 3 times x, which is 2, plus 2 times y, which is 3, equals 12. 3 times 2 is 6, plus 2 times 3 is 6, equals 12. 6 plus 6 is 12, so 12 equals 12. That's good. So this is the solution to the linear system. So that's how you do substitution. You're going to, as I showed you in the steps before we attempted this problem, you're going to solve for y from one of the two equations if it's not already given to you. And then you're going to take that y, plug it into the other equation, and that's going to give you an equation that's only in terms of x. So you solve for x, and you get its solution. We got x equals 2. And then you plug that solution into either of the equations, doesn't matter which one, and solve for y, and that's going to give you your y value. That'll give you the solution of the equations, but to check your work, it's always good to test it by plugging it into both equations and making sure it works. Okay, now I'm going to explain the second type, which is elimination. I actually like using elimination better. It requires less steps, and it's, in my opinion, a lot easier. Not saying you should always take the easy way out. So the first step is to multiply. I can't spell. Multiply equation 1, equation 2, or both equations by a constant or by constants to get equivalent equations in which how do I put this? In which the coefficients of one of the variables, could be x or y, is the opposite sign, plus minus, of the other. So you want one equation to have a negative constant, or a negative coefficient, and the other equation to have a positive coefficient, where the coefficient number is the same. For example, you can have a positive 5y in one equation and a negative 5y in the other equation, so that they cancel out. Makes it a lot easier to solve for x, or in the other case, solve for y. And then the second step is to add equation 1 to equation 2. So you're going to add the two equations together, and then you're going to solve for the remaining variable. And then, as always, check the solution. You always want to check your solution to make sure it works. So go ahead and copy that down, pause the video if you need to, and we're going to move on to, we're actually going to use the same example as last time so that you guys can compare how it works. So we're going to look at the same two equations and get the same solution. And you don't need to check it this time since we're doing the same exact thing, as long as we get 2, 3 as our solution of the system. So we have 5x plus y equals 13 again. And then we have 3x plus 2y equals 12. Okay, so the first step was to multiply one or both of the equations by a constant or by constants to obtain equivalent equations in which the coefficients of one of the variables is the opposite sign of the other. So what we have right here is a 5 and a 3 for coefficients in front of the x. We can't multiply 3 by anything to get 5. And we can't multiply 5 by anything to get 3 because 3 is smaller. So let's look at the y. We have a 2y and a 1y. So can we multiply 2 by anything to get 1? No. We don't want to work with fractions. Can we multiply 1 times anything to get 2? Yes. So we're going to multiply this whole equation by 2. But that's going to give us 2y and 2y. We need an opposite sign so that we can subtract them. So let's multiply by a negative 2. So that's going to give us a new equation, which I'm going to write down here in black again. So negative 2 times 5x is negative 10x. Negative 2 times y is a negative 2y. And you also have to multiply it by the opposite side, the other side, the right-hand side. So negative 2 times 13 is negative 26. The second step was to add these two equations together. So we're going to add this equation and the new equation that we got together. So 3x plus a negative 10x is 3x minus 10x gives us negative 7x. 2y minus 2y is 0, so those cancel out. And 12 minus 26 gives us negative 14. This already looks familiar. We solved for x and we divided by negative 7 and we got 2. Now from here on out, that's the only difference, is this first step. From here on out, you're going to do the same exact thing you did before. You're going to plug this in for one of those, and it's going to give you y equals 3. So the only difference is that we're multiplying one of the equations by a constant in order to cancel out one of the variables. Now we could have multiplied both equations by a constant in order to cancel out the x's, but it's more work and it's not very necessary. But in the case that you had y, or let's see, let's say you had, let me think, 3x minus 5y equals whatever, 5, and then 4x minus 7y equals 6. So these, you can't multiply one by the other to get anything. You can't multiply one of these by another number to get something, the same exact number. So in this case, we have to multiply both equations. So you have to multiply both of these to obtain a new one. And what you can do is you can multiply this one by 7, this one by 5. That's going to get you two negatives though. So you'd have to multiply one by a negative, one by a positive. Or you can multiply this one by 4, this one by 3. Again, one of them negative, one of them positive. So if we multiply this by negative 4 and this by positive 3, that's going to give us two completely new equations. And what it's going to give us is, for this equation, we're going to get negative 4 times 3 is negative 12x. Negative 4 times negative 5 is 20, and that's y, equals negative 4 times 5 is negative 20. And this one, 3 times 4 is 12, that's x. 3 times negative 7 is negative 21, and that's y. Is 6 times 3 is 18. Now we have our variable that we can cancel out, and that's the one we're trying to cancel out. 20 minus 21 is negative 1, y. Negative 20 plus 18 is negative 2. So y equals 2 when we divide by that negative 1. And then you're going to plug that in for one of those and solve for x. So that's what happens when you have to multiply both equations. I just wanted to show you that because we've been working with equations where you only have to multiply by one of the equations by a constant. This is where we had to multiply both. So that's just one example. Okay, so we've worked with equations where we get the same solution. What's going to happen if we have two parallel linear equations? Well, parallel is when we have the same slope. So let's say y equals 2x plus 3. And then 3y equals 6x plus 21. So let's make this in the form of y equals mx plus b. So we're going to divide the whole thing by 3. And that's going to give us y equals 2x plus 7. So these are two different equations because they have two different y-intercepts. This one has a y-intercept of 3, this one has a y-intercept of 7. But they have the same slope, which is 2. So they're parallel equations. They have the same exact slope. They're never going to intersect. So let's look at the substitution method for this one. So I'm going to erase this equation, and we have y equals 2x plus 7. Actually, elimination is a lot easier in this case because we have the 2's. So we only have to multiply this by negative 1. So let's just multiply that by negative 1. And we get negative y equals negative 2x minus 7. Now we can add. Y minus y is 0. 2x minus 2x is 0. 3 minus 7 is negative 4. So we have 0 equals negative 4. That doesn't make sense, right? Well, that's what happens when you have two linear equations that are parallel. You're going to get some number equals a different number. And that means that they're parallel and that they're never going to intersect and there's no solution. So we can write no solution. Now, what happens if we have infinitely many solutions? I already showed you that, but we didn't solve for it. It was, I don't remember the exact problem. I think it was y equals 2x plus 3 or something. Well, let's look at the y equals 2x plus 3 again. And then let's just make it 2y equals 4x plus 6. Well, these are the same equations because if we divide by 2, we get y equals 2x plus 3 for that one. If we divide the whole thing by 2. So we have y equals 2x plus 3, y equals 2x plus 3. These two are exactly the same. So let's do elimination again because it's so much easier. And we're going to multiply by a -1. What's that going to give us? That's going to give us the exact opposite of the equation. So we're going to get -y equals -2x minus 3. Now everything just cancels out, and we get 0 equals 0. It's not always going to happen where you get 0 equals 0. You might get like 3 equals 3, or 4 equals 4, or -1 equals -1. But whenever you have one number equals another and they're both the same, it means that they're the exact same line. And that there's infinitely many solutions. That was a bad infinite sign. So infinitely many solutions. And that's it for this. There's no homework except out of the textbook. Just try a few of those problems. I'll post the homework on the teacher website. So good luck with that. If you have any questions, feel free to email me.